All right, so now we're going to get into 13.4, Measures of Validity. Well, that sounds like really big words. So what that is saying is we're going to take a lot of information, we're going to do a lot of steps. This is a pretty big assignment. It's going to take you a little while to do it, but if I understand Chapter 12, mean, median, mode, and range, and how data works, and I understand 13.2, box plots, and I understand 13.3, that standard mean deviation, then I'm going to be okay. Or it also means that if I follow along, if I focus on what Mr. Barker is saying on the video, I don't fast forward, I show all of the steps that he's asking me to do and shows me as we work through these problems, I'm going to know exactly what to do on my assignment. So let's get into it. Measures of validity, or variability, excuse me. So when I talk about variability, then we're looking at all the different types of ways that I can compare information. So it says, in gym class, the students recorded how far they could jump. The data set below, right here, talks about manual, and in inches, how far manual jumped. What is the mean absolute deviation of the data set? That was the last video, right? 13.3. Well, always before in 13.3, they told me my mean. It's not that nice to me this time. I have to start by finding my mean. Now I have to think back to Chapter 12. What does mean mean? Mean means average. So I know I have to take all of his pieces of information, add them together, and divide by how many are there just to get to my mean before I can do my mean average deviation. So I know I have a 54, and then a 55, and then a 56, and then a 58, and then a 59, and I end with a 60. All right, so I got everything from my data chart written down in my numerator. I have to add them all together, handy dandy calculator. 54 plus 55 plus 56 plus 58 plus 59 plus 60 plus equals, I get a total of 342. I'm going to divide by 6 because there are 1, 2, 3, 4, 5, 6 pieces of information. So my mean of this group, handy dandy calculator again, 342 divided by 6 equals, I know that 342 divided by 6 gives me 57. So my mean, or my average for the group, is 57. My answer's done, right? Not even close. More work to do. I have to have that in order to do all of this. All of this is showing me, here's my original data volume. What is my mean? Well, we found that our mean is 57. So now I got to find the distance between each of those. This is once again 13.3 that we did in the last video. So I go to my mean and I subtract my data point every time. So 57, the mean, minus 54 is 3. Now they don't have these in order from least to greatest, which is fine. It just makes it a little trickier to remember if I'm subtracting the mean or subtracting the number from the mean. So as long as it's larger than the mean, I have to do it first. So then I take 58 minus 57. Well, from 57 to 58, that's 1. So once again, I'm going to use this information. I have 1, I have 56, so I'm going to take 57 minus the 56. That's 1 again. 59 and 57. So 59 minus the 57, that's 2. 60 minus the 57, that's 3. 57, the mean, minus the 55 because it's a smaller value, that's 2. So once again, the 57 came from finding the mean up above, and I'm going to take each of my data points and I'm going to do a subtraction problem just to figure out the distance on the dot plot from the mean. The way I do that is I take all of these and I add them together and I get my total. So my total is 12. So it's going to go here. And then I divide by how many are there. So I'm finding my overall mean of all the data. Then I'm finding the deviation, the steps from the mean, and averaging those. So I take 12 divided by 6 and I get 2. So I know the mean absolute deviation, the average step away from the overall mean or average, is just 2 inches in his 6 different jumps. All right, so we remember how to do that. Well, what about these things? Oh, let's see, those are box plots, and we know box plots show us a lot of information. They show us the smallest number and the largest number, all right, and then we found the mean, so that was the middle number, and that's what's inside the box. And then we found the mean or the average of the first group, and that was my, what was it, lower quartile, right? And then I found the second group, and what was that one? That one was the upper quartile. All right, so I know I have smallest, largest, lower quartile, mean or average, and upper quartile. All right, I remember those. So let's see what it's asking. If the box plot shows the price in dollars of a handheld game player of 2 different electronic stores, find the range and the interquartile range for each data set. And what are those? Well, range, I introduced to you in Chapter 12 with mean, median, mode, and range, like the golf range. From where I'm hitting it, how far does it go? The distance from the biggest number to the smallest number. That's all range is. Taking my largest number and subtracting it. So that's these outside points on a box plot. The interquartile range is just the difference between the upper quartile and the lower quartile, subtracting those to find out the difference between them. So these 2 points I would end up subtracting. All right, I can do that. I can take that, a basic subtraction, and those 2 as a basic subtraction. I can do all that. So let's solve for it. If I know I'm going to use my red ovals for my range and my blue lines for my interquartile range, then I know I'm going to have 150 minus 24 for range for store A. So 150 minus 24, when I stack them and subtract, I know I get 126. So the range for store A is 126. My interquartile range is my upper quartile, my lowest quartile, subtracting those. So 72 minus 48. Well, 72 minus 48 is 24, so I know my interquartile range is simply 24. Now I'm going to do store B. This is store B's. I'm going to look for my range, and that's my lower and higher numbers. So I'm going to take 120 minus 30. 120 minus 30 gives me 90. So I know my range for store B is just 90. My interquartile range, that's my box plot, my highest, my lowest, my upper quartile, my lower quartile. 100 minus what? Well, that one shows me 42. So 100 minus 42 is 58. So I know my interquartile range for store B is 58. So now I compare the data. Store A has a greater what? Well, I'm comparing 24 and 58, not the interquartile range. How about 126 and 90? Yeah, so it has a bigger overall range. Where store B has a greater what? Well, we just looked, 58 is larger than 24, so it has a greater interquartile range. The only way I'm going to find those is by being able to interpret my box plot and know what those numbers are that it's showing me. I can do that. Shouldn't be difficult. All right. So we're jumping quickly into the share and show, because all this is marrying all of those pieces of information from being able to find the range, being able to find the mean in Chapter 12, to doing lesson 13.2 and 13.3 together, all in one step. So find the range and interquartile range of the data in the box plot. All right. So for the range, find the difference between the greatest and the least values. Well, my greatest and my least. So when I look at them, my greatest is here, or my least is here, my greatest is here. And what numbers do those represent? So from 5, 6, 7, and from 20 back 1, that's 19. So my largest number is 19, my smallest number is 7. I do a simple and basic subtraction problem. First and second grade, we've been doing subtraction. 19 minus 7 is what? 19 minus 7 is 12. So I know my range is 12. 12 what? Well, they go ahead and put the label for me on the line, $12. My interquartile range then is going to be my lower quartile and my upper quartile. And what measurements do those give me? Well, I start at 10 and I have 11, 12. So my lower one has to be 12. And it's right on the 15. That makes it pretty easy to see. So I know I'm going to have 15 minus 12. And when I do that, that's just simply 3. So my interquartile range is 3. 3 what? $3. Pretty easy, right? Not designed to be difficult. It's just remembering what that box plot is telling me and interpreting the data and what to do with it. Well, what about this? So this is 13.3. This is finding the mean absolute deviation. So I have to know what the mean is, and then I have to find out what the deviations are to find the mean absolute deviation by averaging them together. So a lot of steps, but nothing really difficult when it comes to the math. So I want to find out what the mean absolute deviation is of the heights in inches of several tomato plants. All right, I can do that. So what is my mean? Well, I have to add them all together and divide by how many are there, right? Because mean means average. And averaging is a two-step process. Find the total, divide by the number that's there. So I'm going to take, and I always like putting mine in order from least to greatest, because it may suddenly ask me, well, what's the median or what's the mode? And that makes it easier to see. I'm just going to pick up my handy-dandy calculator and type all of those together with addition signs, and I'm going to see that I get 144. That's just my total. It's not my mean, because then I have to divide by how many are there. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces of information. So I take my 144 and I divide by 8, type in my handy-dandy calculator, 144, inside number. The dividend is always divided by the outside number, the divisor, to get my quotient. So 144 divided by 8 gives me 18. So I know my mean is 18. Is that my answer? Not my answer, is it? Because this is my mean absolute deviation. The amount of distance, average distance from the mean for all of these values. All right, so now we're going to use the 18 and I got to find the distances. So I'm going to have to subtract every time. I have 1, 2, 3, 4, 5, 6 that are less than or equal to the 18. So I'm going to have to take my 18 and subtract those. I have 2 of them that are greater than 18, so I got to do those and take 18 from it. Have to get positive numbers. Can't use integers on this, as I said in the last video. So 18 minus 16, 18 minus 17, 18 minus 17, 18 minus 18, 18 minus 18, 18 minus 18, 20 minus 18, and 20 minus 18. And I plug all of those in, and what do I get? Well, basic subtraction, right? I have 2, I have 1, 1, 0, 0, 0. The bigger number minus 18, still 2 and 2. All right. Now, going back to the last lesson, once I have found all of their distances, I want my mean absolute deviation. So this is all of the deviations, and now I got to find the mean of it. Got to average them. So I add those all together, and I get 8. 2 plus 1 plus 1 plus 2 plus 2. Okay, so that's 8. And there are how many once again? 8 of them, right? So I take my 8 divided by 8, and what do I get? I get a deviation of 1. 1 what? Well, it says heights in inches, so just 1 inch. Not difficult, but a lot of steps. And if you don't have it written down and ready to move on, then pause the video now and then come back to it. All right, so question 3 then says, I'm going to do the same type of information here because it goes under those directions, but this one's about times and seconds for students to run 1 lap. All right, so let's see how long or how quick some people can run a lap. I first have to do what? I got to find that mean again. That has to be my first step. The book's not as nice to me this time. I have to do the work. So once again, I'm going to add them together. I put them in order from greatest to least, and I add them. Handy dandy calculator, type it in. It lets me just get 324. That's not my mean, that's my total of all of my values. Now I have to divide by how many are there. 1, 2, 3, 4, 5, 6. So I have 324 divided by 6. So I write down 324 divided by 6, type in my handy dandy calculator, and I see that my quotient is 54. So my mean, my average time it takes to run around the lamp is 54 seconds. That's not my mean absolute deviation, is it? Now I have to find out what it is every time for each of these, the distance from the original value and the mean itself. So I'm going to have to take my 54, I'm going to have to subtract the smallest numbers, and then the larger numbers, I'm going to have to take the 54 from it. So I plug in the numbers that I have, and I have 54 minus 40, 54 minus 40, 54 minus the 52, and then I have my larger numbers. 60 minus the 54, 64 minus the 54, 68 minus the 54, and I do each of those, and that goes back to some very basic subtraction. 54 minus 40 is 14, I have 2 of those. 54 minus 52 is just 2. 60 minus 54 is 6. 64 minus 54 is 10, and 68 minus 54 is 14. If you don't have those written down, pause the video now. Make sure you get it written down before you move on. Once you have all those written down, then that's when I have to find the mean of those values. So I add them all together and I get 60. And I divide by how many are there, where there were 6 students that participated, because I have 6 different values. So the deviation, my average distance from the average amount of 54, or the mean amount of 54, is going to be the 60 divided by the 6 students. And that tells me that my mean absolute deviation is 10. 10 what? 10 seconds. Not difficult, but it is a lot of steps. I just have to write it down, and then when I do my mid-chapter checkpoint tomorrow, I can come back to my book and see all of these steps and remember the process that we followed to get to that answer. Moving on. Use the box plot for 4 and 5. So these two go together. What is the range of the data? So range, okay, so once again, that was just my numbers, right? So my range was my largest number, and I take away or subtract, I find the difference with my smallest number. So what are my numbers? Well, I have my smallest one, my largest one, that's 30, 31, 32, and this one is 50, 56. So I know I'm going to subtract my largest of 56 with my smallest of 32, and I get 24. All right, so 24 what? How did I get dollars? Well, once again, the box plot shows me what my label is going to be, and then it's going to be dollars. What is the interquartile range? That's those quartiles, right? Lower quartile, upper quartile, the ends of the boxes. So what do the ends of the boxes tell me? Well, this one, 36, and that's 50, so 51, 52. So now I'm going to take 52 and subtract 36 from it. And when I do that, I get 16. So my interquartile difference is simply $16. All right, I can do that as well. So what does this say? Find the mean absolute deviation for the data set. Well, we've already done a couple of those. So guess what it's time for? It's time for you to work these out, and let's check your work then once you're done and see how you do. So this is where I want you to pause the video. I want you to do the work and come back and unpause it so you can watch it. I could just stay there for a couple minutes and take a drink and wait for you to come back. Oh yeah, we should be unpausing now, right? Because right now we should be unpausing because our work is done. So let's see how we did. I have times and minutes spent on a history quiz, and this is how long it took in minutes for all of the different students. I want to find my mean absolute deviation. So I have to do my first step, finding my mean. My second step, finding all my deviations, my distances from the mean. And then I have to average those together. So you should be showing me a lot of different work here. First thing you should show me is that you're adding these together, all of these data points, to get my total then a division problem to find the mean. So the total you should have gotten is 272, and then you should have counted how many there were and divided it. That just gets you to the mean. The mean, therefore, is 34. Then you should show me that you're going to use the mean of 34, and I'm going to subtract it from, or subtract the numbers from, that mean, each of these data points. So I should see on your paper, data points showing me the next step. Now, if you needed extra paper, scrap paper, that's fantastic. Use scrap paper. I'm fine with that, by all means, as long as I can see your work, and more importantly, you could go back and look at your work for all of the upcoming assignments. So I should see all of these little subtraction problems so you know you've included all of your data sets. And their basic answers of 2, 2, 0, 0, 0, 1, 1, and 2. Then, another step. Then you added those together to find their total. And when you added those together, once again, we got an 8. Well, how many points are there in the data set? There are 8. So once again, I get my basic division problem of 8 divided by 8 to tell me that my deviation is just 1 minute difference between all the students to take the quiz. All right, so let's see how you did on number 7. Now, if you didn't do number 7 yet, then go ahead and pause the video now before you move on and check your work. If you made a mistake here, change it, correct it. That way you don't get confused when you go back to it in a couple of days to look at it to remember how to do these. On question 7, we should have started with finding the overall mean of the group. That can only happen by adding them all together. Once again, I like to put them in order from least to greatest or greatest to least. I could flip-flop them, but it helps me see them better. When I add all those together, you should have gotten a total of 50. And then I had to do my division. And my division was how many are there divided by 50. Well, there are 10 pieces of data there. And 50 divided by 10 is basic division of 5. All right, you should be good with that. And then you had to do your next step. And you had to subtract the 5 from the data or the data from the 5. Either way, you're going to have 5 of them where my mean is larger, and 5 of them that my data is larger. They still have to get my positive number. Can't get negatives. So when I did my subtraction then, and I wrote it down on my chart, then you should have answers of 4, 4, 4, 4, 3, 1, 4, 4, 5, 5. Those are all of the deviations that happened in your chart from the mean. Now to find the mean absolute deviation, you totaled them together and got your 38 and divided by how many are there, which we said were 10. So your mean average deviation should be 3.8 as your final answer, because 38 divided by 10, I have to add a decimal and a 0 to continue to divide. I don't do remainders. We haven't done remainders since the first month of school. So I should have a mean average deviation of 3.8 absences, because that's what we're talking about, is excused absences. So now it's time for you to do your assignment. It is a lot of steps, I understand. And where it gets confusing is if we're really not mentally engaged and following along, participating and filling out our book, because then we really don't know what's going on. If all I'm doing is duplicating what I see on the screen and I'm thinking about other things, you're not going to get it. But I guarantee if you're following along and doing what I ask you to do, there's not a one of you that can't do basic addition, subtraction, division, because that's what this lesson is all about. This is your assignment, not that many questions, so all you have to do is work on it, and if you have questions then you can come and ask.